Hello, everyone. So we're going to get into graphing rational functions. But before we do that, I would like to do a review of just graphing features in general. So we should have done this in secondary 1 and secondary 2. So the first thing we're going to do here is we're going to go over all the features and how to find them. Now, I ahead of time wrote my definitions down, so we don't have to take time in this video to watch me write them down. So if it's a long definition and you need me to wait, just pause the video as you write down the definition. So our first definition is going to be domain. Domain are all the x values of that particular graph. And what you always want to do is look from left to right, because when we make our interval notation, you want to go least to greatest. Next would be our range. So range is all the y values of the specific graph. And when you do this one, you look down to up. Pause if you need to, okay? Let's see, X-intercept. So what is the X-intercept? It's where the graph crosses or touches, in some cases, the x-axis, okay? This will always be in a coordinate pair. What happens when it's on the x-axis is y will always be 0. So your answer will always look in the form of a number, comma, 0. The other thing we need to remember is there doesn't need to be any x-intercepts. Some graphs don't even cross the x-axis. But another thing we need to think of is sometimes we have multiple x-intercepts. So there might be more than one. The y-intercept, where the graph crosses the y-axis. And in this case, the x is always 0, so we have the coordinate pair of 0, comma, a number. Do we always have to have a y-intercept? No, not necessarily, because it's just that way our function might have an endpoint and not cross that y-axis, some cases. But the other way is that's different, that you would say from the x-intercept, is that the y-intercept there would only be none or one. There can't be more than one, because if there was more than one y-intercept, it would no longer be a function. Increasing. So here's where we're going to say you write down the interval of where the graph is increasing. So when we read the graph left to right, and hopefully that looks okay when I put my hand that way, because sometimes the reflection does it different. So left to right, the graph goes up. So I made a little drawing as if we were going left to right, our graph is heading up. Now when you write your increasing interval, you use the x values. Many people make this mistake and use y values. Use the x intervals. Decreasing. Again, read your graph left to right, and as you read it left to right, your graph goes down. So your y values are decreasing. But when we write the interval, we use our x values, not our y's. Positive. So when we think of positive, we think of where the y values are positive. So that means everywhere above the x-axis. And yes, again, we're going to use the x values to describe where it is above the x-axis. Where negative, the y values are negative, we're looking below the x-axis. Relative max. Relative max means we are going from increasing to decreasing. So there's a hill. And by the way, it goes increasing to decreasing as we read the graph left to right. So you're looking for that hill. This is a little bit different from absolute max. In the past, you might have talked about absolute max. If you go into calculus eventually, you'll also talk about absolute max. But for now, we're just going to do relative. Relative min means that we're going from decreasing to increasing as we read left to right. So we're looking at a valley. And last but not least in our features, for now, is our end behavior. So end behavior is what's happening at the ends of our graphs. In this time, we're going to look at what happens where the arrow is pointing. So what I want to show you is that when we're talking about the left side of the graph, it looks like this. Limit as x is approaching negative infinity. And our right side is the limit as x approaches infinity. And so what I like to do is when I look at the left side, I look at the arrow and I say, is my arrow pointing up or down? I mean, sometimes it points constant, but for now we're just going to do up or down. If it's up, our answer is infinity. If it's down, our answer is negative infinity. I'm going to do one example with you, and then I want you to do the other three by yourself. Okay, so we're going to do this one together. So domain. Domain is all the x values. Look all the way left, all the way right. If we look all the way left, this arrow tells me to keep going left. So what's the number all the way left? Negative infinity. And if we go right, that arrow tells me to keep going right. What's the number all the way right? Infinity. And we learned in the past what always goes around infinities? Parentheses. All right. Range. Range is your y value, so look down, up. But if we look down, if I took my pen right here and I look down, I see that we stop here. We don't go beyond this point. So that means where we're actually starting for our y value, since it's the least, is negative 8. That is the y value right there, negative 8. And then if we go up, these arrows tell me to keep going up. So I keep going up all the way to infinity. We just discussed that around infinity is always a parenthesis. But what about that negative 8? Okay. Parentheses means that it's getting very, very close to it, but it never hits it. And the reason why we do it around infinity is because we can never get to infinity, right? There's always a number larger. This negative 8, does it hit this coordinate? Yes, it does. If it didn't hit it, you would see a hole, but it hits it. So what we do is we use a bracket. X-intercept. So remember, X-intercept is where it crosses the x-axis. How many X-intercepts do we have in this graph? 2. We have one right here, one right here. Now remember, X-intercepts are a number, comma, 0. So what are those numbers? Well, if you look, that's negative 2. And the other one is 6. Okay, y-intercept, where it crosses the y-axis. So it crosses right here. So that coordinate, remember, is 0, comma, number. So what's that number that it hits? It hits at negative 6. All right, here's my little tricks for increasing, decreasing, and we're not going to do constant this time. I kept these graphs. Constant would be if your graph was going horizontal. I do this a lot for piecewise functions, but right now we're just reviewing some basic functions. Okay, so when I do increasing, decreasing, what I actually do first is I take my finger and I start tracing the graph left to right, and I verbally say what's happening. So all the way left, I'm going to start at this arrow. What am I doing with my finger? I'm going down, and then I'm going up. I'm going down, and then I'm going up. So I'm decreasing first, and then I'm increasing. So decreasing, I'm using the x-axis. So this arrow tells me I'm going all the way to negative infinity, because that's where I'm starting. And then as I decrease all the way to this point right here, right? Because then I start increasing. Well, here's the trick, because most people want to put in that -8, but we're using the x values. And if you look right here, the x value is 2. Increasing, we're going to start at the x value of 2. And it increases all the way right to infinity. Okay, positive, negative. My little trick here, what I like doing, is I like circling as I read left to right. So if I see on the left side here, I'm above the x-axis till right here. Next, I'm below the right axis, x-axis, and then here I'm above. Now, the reason why I circled this is because of these reasons. How many circles do I have above? I have 2. That means I'm going to have 2 intervals. Where below, I only have 1 circle, so I'm going to have 1 interval. So I like going left to right. You can do both your positives at once and all your negatives at the other. I like going back and forth. So I'm above the x-axis here, so I'm going to start here. That arrow tells me I'm starting at negative infinity, since I'm talking about the x values, and x over here is negative infinity. And then in positive, all the way until that x-intercept, which is at -2. Then I become negative at -2, all the way to this x-intercept, which is 6. And then I'm positive again from 6 and all the way right, because this arrow tells me go all the way right to infinity. I want you guys to understand that there is a connection between positive and negative with your x-intercepts. If these numbers are different, then you use the wrong value. Mostly you use the y value and not the x. All right, relative maximum. Well, max would mean that there is a hill. Do you guys see a hill here? No. So you can say NA or none. But what do we see? Guys, I see a valley. I go decreasing to increasing, and that is a min. So when we say min, we're going to just write that coordinate down. That coordinate is 2, -8. As you can see, there's a connection with relative min with the increasing, decreasing, and the range. It doesn't always deal with the range, but it does have a connection, the x value, with the increasing, decreasing, the x value. Not always the range, but in this case, the range. Okay, so right here, I wrote the limit notation for you for end behavior, but I want you to review what this means. When this says limit as x approaches negative infinity, what side is that talking about? It's talking about the left side, because where x is negative infinity is all the way over here. So I'm going to look at the left arrow, and that left arrow is going which way? Up, and up means infinity. Now, limit as x approaches infinity. Well, x to infinity is over here, which is to my right. So if I look at that right arrow, which way is it pointing? It's pointing up, and up also means infinity. These will not always be the same. Be careful. So there's 3 graphs I want you to practice this on. Okay, and there's 2 on the back, so don't forget the back. I have you just practicing some different graphs, and then we'll go into rational functions. Good luck, guys.